Keys and constraints. In this nugget, we're going to dig a little deeper into data integrity. So we'll start with a refresher on the different levels of data integrity, from entity to domain to referential, and then we'll start digging into specific constraints and see how to build them in SQL. So we'll talk about primary keys, foreign keys, check constraints, unique constraints, null constraints, and default constraints. Let's get started. Now, back in our normalization nugget, we built a database from scratch. And we're going to use this same database here to enforce data integrity because we don't have a lot of integrity on this database as it sits. So this is a database that is built to track learners and their certifications. Now we're going to start here with entity integrity. So remember, entity integrity is integrity enforced at the table level. And we have primary key constraints to do that. Now the definition of a primary key constraint is that it uniquely identifies each record in a table. And we need that. We need unique identification, otherwise we're not going to be able to find specific records. So a primary key is really just a unique constraint and a not null constraint put on a column, because your primary key cannot contain any null values and it must be unique. You can only have one primary key per table, but that primary key can consist of multiple columns that make up the key. Just like we have here with our learner certifications table. Learner ID by itself is not unique, because a learner can have many certifications. So we may have that specific learner ID in here many times. And a certification is also not going to be unique by itself because multiple learners can acquire the same certification. But the combination of these fields makes that record unique because a learner is not going to acquire the same certification multiple times. So every table should have a primary key, a way to uniquely identify a record within a table. As we saw, that was one of the rules of normalization. To be specific, that is one of the rules of first normal form. Now, next up we have referential integrity. And remember, this is how we enforce data integrity across tables, between data within those tables. This is how we configure relationships, right? And we enforce these through what are known as foreign keys. And a foreign key references a primary key in another table. And this is what allows us to keep one copy of the data, master record in one table, like we have here with certification. We have a certification ID that represents the actual certification name. And then we put that primary key as a foreign key in another table, like we have here with learner certifications. We can associate learners with certifications. And like we have down here with exams, so we can associate exams with certifications. We have our certification ID as a foreign key in the exam table and as a foreign key in our learner certification table, which coincidentally is also part of the primary key in that table. Now we're going to take foreign keys to the next level in this nugget by talking about what we can do when data modifications occur, when referential integrity is involved. Up to this point in our demonstrations and our labs, what have we been doing? We've just been disabling the constraint and getting around it and totally ignoring referential integrity. There are better ways to do it. In fact, we're going to take a look at cascading options, because we have options when we're dealing with reference data, right? Let's say, for instance, that we have a certification that is old, it's retired, it's going away. Users or learners no longer have these certifications, they've been retired, they're no longer valid. So let's say we wanted to delete a certification. Well, with referential integrity, we're not allowed to do that. SQL Server would yell at us and say, no way. But we have options that we can specify on these linkages, on these relationships, on these foreign key constraints here that say do something like cascade a delete. So if we delete the parent record, it'll go and delete all the children record in those associated tables. Or maybe we had to update the ID. Then it can cascade update those referenced IDs to match the modification that we made here in the parent table. So we've got a lot of different options there, and we'll explore them when we get into the virtual Nugget Lab. Now, domain integrity, remember, is column level integrity. And we can enforce this a number of ways. We've got a lot of different options here. One that I didn't list is data types. Remember, data types is a great way to enforce column level integrity because it restricts the kind of data that can go in the column. Another one is a check constraint. In fact, when we get into the virtual Nugget Lab, we'll build a couple of check constraints, one on the name column here, the vendor, and one on the cost column here in exam. And a check constraint just allows us to specify valid values for the comment, or a range of values for a column. For instance, on the name column and vendor, we're going to say that we only work with a list of vendors, and we only want these list of vendors inside of the table. So we'll put a list of those vendors, bind it to that column, and no other data will be allowed to enter that table for that column. In our exam table, we're going to say, you know what, exams only always ever cost between $100 and $200. So we will put a check constraint on there to ensure that no records can be entered where the cost column is anything outside of $100 to $200. And any data that tries to get in with any other values will get rejected. Default constraints allow us to set up just that, a default. So if a value isn't supplied for a column, it'll pick up the default value. Pretty straightforward there. We'll take a look at how to add default constraints. And we also have unique constraints. This is what's going to allow us to guarantee that a column is unique. So if you have a column that you want unique values in, and a good one here would be the exam name. No need to have multiple exams of the same name inside of our table, right? That could cause some data integrity issues down the road. So we'll pop a unique constraint right on that name column, which will ensure that that column is always unique. There will never be able to be two exams with the same name ever inside of that table. Finally, we have null constraints. And again, we've been working with null for quite a while up to this point in the course. This is how we are going to require data or mark data as optional. Null means optional. Not null means required. And this is also the nullable property that you'll see when you're defining your columns inside of a table. So if you want to require data for a column in a table, you will specify it as not null. And null, by the way, is also the default. So if you do not specify a value, it will be nullable or optional by default. All right, let's head into the Virtual Nugget Lab and take a look at how to work with all the different kinds of constraints in SQL Server. Welcome back. We are in the Virtual Nugget Lab on our SQL Nugget database server. Let's jump into SQL Server Management Studio. We're going to be working with Nugget 13 here, keys and constraints. So the first thing you're going to do is, if you want to follow along and try this demo out on your own or work with the sample code, run setup.sql. That's going to recreate the test database as we have here and place all of those tables that we created in our normalization nugget here, the design of our learner certification database inside of TestDB, and load it up with some sample data. In fact, why don't we open setup.sql and just take a quick peek inside here. So what this is going to do is drop the database if it exists, recreate TestDB, and switch our context here to TestDB, just like so. Then it's going to create all of these tables and put some sample data inside of it. So here's our learner table. Notice that we have primary key. We are defining the primary key on the learner ID column. And remember, primary key must be not null as we have here. If we try to do something like this, we'll get little red squigglies, which is telling us, no, you can't do that. And in fact, if you look at the error, it's going to say cannot define primary key constraint on a nullable column. Cool. Another thing I want to point out here is our next table, learner certification. Notice right here that we're creating what's known as a composite primary key, a key that is made up of multiple columns. So we're using the constraint keyword after our column definitions, giving it a name here, and then specifying that our primary key consists of both of these columns. And this is one thing I want to point out. When you're working with SQL, you're going to find there's a lot of ways to do one thing. So you can create your constraints while you're creating your tables, or you can run an alter table statement after the fact and add constraints to the table, which is what we'll be doing from here on out, because this database is partially completed. We've got a lot of work to do to get all of our constraints onto here, but we do have our primary key set up here, and that's what I wanted to show you inside of setup.sql. There is one table in here that doesn't have a primary key, and it's our vendor table. So we're going to need to alter this table and add that primary key constraint to make vendor ID a primary key. Everything else looks good. We have single primary key columns here for everything else inside of this database design. So this looks good. Let's open up one-keys.sql. Now you can also see this visually using Object Explorer. In fact, let's expand our certification table and our columns, and the gold key denotes that we have a primary key. This is our primary key on this column. We can also expand the keys node to see our primary keys under it. And now since we added the primary key as an attribute to the column definition, and just to show you what I mean there, if we open up setup.sql and head down to certification, see this right here? We just added the primary key as an attribute. So it generated a random name here for this primary key, which may or may not matter. It depends on if you plan on referencing these keys in scripts down the road. But if we take a look at learner certifications, look at this table, expand columns. Notice here we have two columns that make up the primary key. And you can tell it's still only one key, but because if we expand keys, there it is. And notice I named this one. Head back to setup.sql here and scroll down learner certifications. We named it right here. Constraint, name of the constraint, primary key constraint, and then the columns that are associated with it. Let's take a look at that vendor table. Oh, no primary key. If we expand keys, there's nothing in there. So we're missing the primary key in this vendor table, and that's what we're doing right here with our first statement. Let's switch our context to TestDB, and then we're going to alter the table vendor, add constraint, give it a name, PK vendor, and this is going to be a primary key on that vendor ID column. Let's go ahead and hit execute. And now if we refresh our columns, we're going to see a key there. If we refresh our keys, we're also going to see the key is there with our user supplied name. So very simple to add keys after the fact. You can also just go into design mode of the table, highlight the column, and click the key. Oh, there I turned it off, but you can also turn it back on. And I'm just going to X out of this and hit no to saving it, so we're back to the state we were there after we ran this statement. Next up, let's take a look at foreign keys. And what I want to do first is show you how to do this in SQL, and then we'll wire everything else up using our database diagram. So inside of the designer there, using a little bit of drag and drop. But the first thing we're going to do is set up a foreign key constraint between our exam table and our certification table. Remember, certifications contain exams, right? Usually they have a bunch of exams associated with them. So that means we have a certification with a primary key of certification ID, and we have an exam table that contains certification ID, which is going to be the foreign key. This is how we're going to associate exams with certifications. Now, by setting up a foreign key constraint like we have been, it would look something like this, where we're just simply going to alter the table exam, we're going to add a constraint and give it a name, and then the foreign key in our exam table is going to be certification ID right here, and it's going to reference the primary key certification ID inside of our certification table. So if we were to just execute it like this, it would be just like we've always been working, where we have no actions set up for data modifications. So if somebody tried to delete a certification and it has a bunch of exams under it, SQL Server would raise an error and say, sorry, no, this is protected by referential integrity. But we're going to add some options onto here. We're going to add an on-update clause and an on-delete clause. And what this is going to do, we've got a bunch of options here, and I'll show you those when we get into the designer. But we've got a bunch of options, and one of them is cascade. So that means if somebody updates a certification, it's going to cascade those changes to the exam table. If somebody deletes a certification, it's going to cascade all the deletes. So all the exams that are associated with that certification are also going to get deleted. So let's go ahead and run this. There we go. And now we have a foreign key set up between our exam and our certification, our foreign key on the certification ID here in the exam table. And we can see that if we refresh it, now we have a silver or gray key inside of here that lets us know that this is indeed a foreign key inside of this table that references the primary key in another table. Now, before we test out our cascade, let's set up the rest of our foreign keys, and I'll show you how to do that graphically, and also take a look at the options here for on delete and on update. So I'm going to get some screen real estate here, just so we can get into our database diagram and take a look at how to do this graphically. So look at what we just did there by adding that foreign key constraint, set up that relationship right there. In fact, we can right click and go to properties, and we can actually see right here that we have our foreign key base table is exam, our foreign key column is certification ID, and our primary key is living inside of the certification table that is certification ID. And check this out. Insert and update specifications. There's your delete rule. There's your update rule. You have some options here. No action being the default. That'll just raise errors if you try to do anything to the data across these tables. Set null means it'll null everything out. It'll make them orphans, which will, you'll be able to identify them using left and right joins. And then you can also set up a set default. So it'll change it to a default value if that's what you want to do. And we have the same options here for your update rule. So that'll give you some options when it comes to controlling what happens to the data when there's relationships set up like we have here. Now, because we named our columns and our tables accordingly, setting up the rest of this should be a breeze, right? Certification ID is going to be the primary key in this table. It's going to link to the foreign certification ID in this table. If you drag them on top of each other, we can see our primary key table, certification. There's our primary key. Foreign key table, learner certifications, also certification ID. So we can hit OK there. Here's again the same dialog that you saw over on the right, where we can specify our delete and update rules. And everything else looks good. You can also expand this to see exactly what your primary key table is, and primary key column, and foreign key table, and foreign key column. So this looks good. Let's hit OK, and boom, we've got a link there. What about vendor? Yeah, right. Here's vendor ID, primary key in our primary key table, linking to our foreign key, which is the vendor ID in the certification table. And finally, learner here, right over here to learner ID. So now we can associate learners with certifications and certifications with learners. Finally, we'll just hit the save button. That'll persist all of those changes. We'll hit yes here, and we're good. Now we need to do one more thing in order to ensure that cascading will work. Because what we want to do is we want to delete a certification, and we want all the exams associated with it to go away, and we want all the learner certification records associated with that certification to go away. What didn't we do? We didn't set up our delete rule on our other foreign key constraint that we created here. So if we go back into the properties and head down to insert and update specification, and let's change our delete rule here to cascade. Now we've got cascading set up on both sides. And let's just go ahead and save that and say yes, and boom, there we go. So now we've got cascading set up on both foreign keys that reference this table. So we'll be able to delete a certification, and it'll flow. That delete will flow through exams as well as learner certifications. So let's close out of this and test it out. So I threw a query together here that we can use to verify once we delete a certification if it's actually gone. So this will pull back all of the learners and their certifications for the vendor, Microsoft. We're grabbing this from the certification table, we're tying the learner certifications in, the learner in, and the vendor in, so we can access all that information. And here's the results. All of our users, their certifications, and the date that they acquired them. Now, notice we've got Bob here, record number 3, and Judy, record number 5. They both have Windows MCSA certifications. We are going to delete that certification, and we should see that delete flow through into the exams as well as into the learner certifications. So they will no longer show up in the query above. So we deleted it. It deleted that one row. Did it flow through to the other rows? Let's find out. It did. They're gone. We can actually verify that by opening up the exam table. Let's go ahead and edit the top 200 rows. And it's gone. Remember, certification ID 3 is the one we deleted, and it's no longer there. And this actually, 412 should have been a part of that, but I accidentally had 4 in here. I fixed that in the setup.sql script, so if you run this on your own, you will see that this record will also be gone. All right, let's move on and take a look at all the other constraints here that we've talked about. First up, we have check constraints. Remember, a check constraint is used to limit the actual values that can go inside of a column. So data types constrain the kind of data. Check constraints constrain the actual data. So we're going to add a check constraint onto our vendor table on the name column. We're going to say these are the only 4 values that are allowed inside of this column. So let's go ahead and create that constraint. And you can actually see this as well in Object Explorer if we head down to vendor and let's head down to constraints, and there it is. There is our check constraint. So now if anybody tries to enter anything that isn't one of those 4 values into this table, it's going to give us an error. And it's going to say, sorry, you're violating the check constraint. Now, we do not have Citrix in that table, so if I edit the top 200 rows, let's add another record here for Citrix. What's going to happen? It's going to be fine, because that passes the check constraint. And so that's how you define check constraints, right? You set up a constraint. You can do this upon table creation, or you can alter the table to add a check constraint, pass in an expression, column name equals value, or in a list of values, or is a range of values, so on and so forth. In fact, our next example here is going to work with the exam table. And here, we're going to add a check constraint for a range of data. We're going to say that the cost should always fall between $100 and $200. So we'll add a check. That cost is between those 2 values. And if we hit execute there, we're good. And now, if we try to update any existing exams to change it above that or below that value, it's going to say, sorry, you're violating the check constraint. So that works both for inserts and updates. Anything that happens to the data in that table will be checked against these check constraints. Let's take a look at a unique constraint. So again, a unique constraint just enforces uniqueness inside of a column. That column will never be able to contain more than one of a single value. So here we're going to alter our exam table. We're going to add a constraint, give it a name here, and we're going to specify the unique keyword and pass in the column or columns that we want to guarantee are unique. In this case, we're going to do the name column. No need to have more than one of the same exam inside of this table, and we can enforce that by putting a unique constraint on that name column. So let's go ahead and execute that. That'll create it, and now we already have an exam 70-461 querying SQL. So if we try to insert that again, it's going to say, oh, sorry, you violated the unique key constraint. Now you can see these in the exam table. Let's just take a peek here. If you expand constraints, we're just going to have check constraints inside of here. If we expand keys and refresh this, you will see there is our unique, because a unique constraint is actually just a unique index, and we'll cover indexes here in a future nugget. Moving on, let's take a look at default constraints. Again, a default constraint is there to provide a value when none is provided whenever inserts go into our table. So here we're going to alter the exam table. We're going to add a constraint, give it a name. We're going to specify this is going to be a default constraint, and we're going to set our default as 150 for the cost column. We're going to say, you know what, most exams cost 150 bucks, so why not just make that a default? So people won't have to supply that value unless it isn't 150. So we're going to alter our table exam here. We're going to add this default constraint to it. And now there's a couple of ways to do this. Here's 2 insert statements. One of them specifies no columns. So we don't have a column list here, which means you're going to need to actually provide a value for all the columns in the table. And if you want to provide the default, you can use the keyword default. If you do specify columns, you can actually omit any defaulted columns and omit the value, and it'll fill in the default for you. So here we're going to add a new exam here under the CompTIA vendor for certification ID A+. We're going to add the 901 exam, and if we hit execute here, it's going to add it in there, and it should have picked up the default because we didn't supply a value and we specified a column list. And if we open up the table here, we should see there it is, and there's our default value that got placed in there. And you can also see default constraints underneath constraints here in Object Explorer. There it is. Finally, we have our null constraint. Now, in order to change nullability of a column, you will need to alter the table, run an alter column, and redefine the entire column. Another way of doing this is just using the designer. So you can head into the design mode of any table, and let's say our vendor ID and name on our certification table, we would absolutely not want to allow nulls on. So we could just uncheck them and save it. Now this is only going to work if you do not have null values in that column. If you do, you'll need to take extra steps prior to doing that to fill out those columns with null values with values. And finally here, if you want to drop constraints, you can do it in the designer here or in the Object Explorer just by right-clicking and choosing delete, or using SQL, alter table, table name, drop constraint, and the name of the constraint, and that'll get rid of them. In fact, if we wanted to execute this statement to drop our exam cost default, we can highlight that, hit execute, and now if we refresh constraints, it's gone. In this CBT Nugget, we took a big look at keys and constraints. We covered all the different levels of data integrity, from entity integrity to domain integrity to referential integrity, and looked at all the different constraints across all of those levels. Primary keys, foreign keys, checks, uniques, defaults, and nulls. I hope this has been informative for you, and I'd like to thank you for viewing.